Welcome, geometry students, to the homework help video. Let's go ahead and get started with the following problems. Numbers 1 through 4, the directions say to determine whether the statement is true or false. Explain your reasoning. So you must give an answer or an explanation on each one, okay? Alright, here we go. I think it would help before we get started to go ahead and copy the little triangle here. And that's definitely not a good way to do it. Let's copy the little triangle like this very quickly. F, E, G, and the big triangle then also. F, D, H. Now remember, students, anytime you have a triangle and you draw a line inside the triangle connecting two sides, so this parallel to the third side like this, the two triangles are always going to be proportional or similar, and here's why. They share a common angle here, so this angle is congruent to this angle, and because of corresponding angles, two parallel lines cut by a transversal, we know that corresponding angles have to be congruent, so we know these two angles are congruent, and anytime two angles of one triangle are congruent to two angles in another, then the two triangles are similar. So understand that these two triangles here are similar. I'll put a little similar mark right here between them. They're similar. Okay, with that in mind, let's go ahead and get started. FE, this side here, over ED equals FG over GH. That is totally correct. Anytime you have a triangle in which a side connects two sides parallel to the third side, it divides these two sides up proportionally. So if you want a reason for that, it would be theorem 8.4. Okay, so theorem 8.4 is the explanation for number 1. Okay, it divides the sides up proportionally. So true. Okay, number 2, right over here. Here we go. We have FE over FT. So FE over the entire line FT, and FG over the entire line FH. And of course that's right. I mean, that's saying this side here over this side here is equal to this side here over this side here. And that's true because these two triangles are similar. So I guess the reason I would give is sorry guys, sides of proportional triangles are sides of similar triangles are proportional. If two triangles are similar, their sides are proportional. Okay, number 3, we have EG right here. This side here, EG over DH equals EF over DF. Okay, so EG over DH equals EF over DF. Totally. That's exactly right. So yes, that's true. And the reason would be similar triangles have proportional sides. These two triangles are similar. And lastly, we have ED over EF. So ED over EF equals EG over DH. No, we don't have any theorem, corollary postulate, or anything that supports that at all. No, that is not true. I just don't see any comparison at all. I mean, ED over this. If you said ED over EF equals GH over FG or so, that'd be fine, but not this at all. No, that is not true. It's false. Okay, moving on to numbers 5 through 8. The directions say determine whether the given information implies that QS is parallel to PT. So we're saying that QR, you know what, let's get these little triangles drawn off to the side like I like to do. So triangle QRS, and then the big triangle here, RPT. Okay, QR this side here over PR. Okay, Okay, so as soon as you state that this proportion here is true, then I know my two triangles are what? Similar, because of side, angle, side. I have an angle that's congruent, and the sides that include that angle are proportional. So listen, if my two triangles are similar, which they are, then I know that this angle here has to be congruent to this angle here. Now as soon as I state that, look, we learned that when two lines are cut by a transversal in such a way that their corresponding angles are congruent, then these two lines are parallel. So I said all of that to say this. Yes, you can definitely state that the two lines are parallel. Now it says to explain explain your reasoning. Okay, I would say this: the triangles are similar, thus corresponding angles are congruent. Lines are parallel. That's it. Triangles are similar, thus corresponding angles are congruent, thus lines are parallel. That's simple. Okay, number 6, we have RQ over, we have RQ over QP equals SR over ST. Alright, now let's think this through for a second. Now remember, students, we looked at a theorem yesterday that said, listen to me carefully, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. But then the next theorem we looked at was the converse of that, and it said if a line divides two sides of a triangle proportionally, then it's parallel to the third side. Well, this line that's drawn has divided these two sides up proportionally to each other. So because of theorem 8.5, yes, those two lines are parallel. So definitely yes. Okay, moving on to this one here. Triangle QRS is similar to PRT. Does that tell you the lines are parallel? Well, yes it does. That's just like number 5, because here's why. So the answer is yes, QS is parallel to PT, because once we state the two triangles are similar, that means this angle is congruent to this angle, which means this angle is congruent to this angle, and whenever corresponding angles are congruent, then the two lines that are intersected are parallel. So what would you say for this? I would say yes, the two lines are parallel, and I would say because of corresponding angles being congruent. That's what I would say. Alright, okay, number 8, we have RQ over RP. So we have this over this equals this over this. Now at first glance you want to say yes, because the two triangles are similar, but hold everything, guys. We know this angle here is congruent to this angle here. You have side angle, side angle, but we've never learned a theorem ever, or a postulate or a corollary that says if two sides of a triangle are proportional to two sides of a triangle and the non-included angle is congruent, then the two triangles are similar. We've never learned that. We've learned if you have side angle side and side angle side in such a way that the included angle is congruent and the two sides are proportional to each other, that's fine. But we do not know, just based on this, that the two triangles are similar. Okay, and so we do not have a theorem that says if the side here and this side here are proportional, this line's parallel. So no, it might be parallel, but we don't know for sure. So no, it is not. Okay, moving on to number 9. Find the length of LM. Now we learned that if three parallel lines are cut by two transversals, it divides the two transversals up proportionally. So we're looking for LM, we'll call that X. So you can say X over 8 equals 4 over 6. Or you can say X over 4 equals 8 over 6. There's other ways you can write it too. Anyway, 6x equals 32. Divide by 6, and we will get what? Let's see, 16 over 3. So the answer is 16 thirds if you reduce the fraction, or 5.3 is also acceptable. same thing. Same answer over here. 4 times 8 is 32. 6 times x is 6x. Divide by 6 and you will get 16 over 3, or 5 1/3, or 5.3. Okay, I'm moving on to number 10. Find the length of xy. Now, we had a theorem that stated whenever a line bisects an angle inside of a triangle, and notice this angle is congruent to this angle, so this line right here is bisecting this angle. In other words, it's cutting it in half. When that happens, it divides the sides over here proportional to these sides over here. So we're looking for the length of xy, okay? X. So we're going to call that X. I guess we should use a different letter since there's an X there. So we're going to go ahead and call that A, okay? So there's many different proportions you could write. You could say A over 3 equals 10 over 5. Or you could say 3 over 5 equals A over 10. Okay? Either way, you're going to get the same answer, which is 5A equals 30. So A equals 6. Or you could say 5A equals 30 and A equals 6. Either way you'll get 6, okay? So the theorem that we learned is if a line is drawn inside of a triangle that bisects the angle, then it divides this side up proportionally with the two sides over here of the triangle. Alright, numbers 11 through 16, the directions say use the figure at the right to complete the proportion. So here we go. We have B. First of all, notice we've got a lot of stuff here, guys. We not only have 3 parallel lines cut by 2 transversals, we got triangles too. We better draw these. We got a triangle here that's called A, B, C. And then we got a bigger triangle that's called triangle A, D, E. Then we got a really big triangle that's called triangle A, F, G. Okay, so let's get those triangles, and notice they're going to be similar because all of these lines are parallel. So this little triangle here is similar to this triangle here, and this triangle here is similar to this triangle here. Okay, all right, which does make this triangle here similar to the big triangle also. So, all right, here we go. BC over DE equals AB. Let's do it over here. It's going to be triangles. Okay, BC over DE equals AB over what? AD. AD. Let's look at it again. BC over DE equals AB over AD, because these two triangles are similar. So AD. Okay. Alright, moving on to number 12. BD over BF. So let's go over here. BD over the whole side BF equals, would it not be CE over CG? Because whenever 3 parallel lines are cut by 2 transversals, it divides the transversals up proportionally. So BD over BF as I realized we were dealing with whole sides of triangles, I jumped over here to my triangles, okay? FA over DA. FA over DA equals GA over AE. It's got to be AE or EA. And there it is. Okay, moving on to the last one here. We have AG, the whole side, over AE. So AG over AE equals AF over AD. That's got to be it, because look at it again. Alright, here we go. AG over AE. So this side over this side equals something over AD was got to be AF over AD. So AF would be correct. Okay. Alright. Guys, I hope this is making sense, okay? Let's continue on. Alright, number 17 through 22. Use the figure at the right. Are you given enough information to conclude that LP is parallel to MO? If you are, state the reason. Now, first of all, let's see here. I was going to draw some triangles off to the side, but I'll hold off. No, I'll go ahead and do that, I guess. We got a little triangle here. This triangle MON. Then we have a big triangle here. That's LNP. Okay, here we go. So we have LM over LN. So this side here over this whole side here equals PO over PN. Alright. Now, let's take a look at this for a second. Okay, students, I'm back and I have studied number 17, and I don't mind looking dumb in front of you students, as long as, it makes you guys think, and they're saying yes for their answer. Now, I looked up their answer in the back of the book to see why they said that, what their why answer was, and it really doesn't make sense. They're saying because the two triangles are similar, then we have corresponding angles congruent, thus the lines are parallel, and I have a problem with that. I'm not so sure the book is accurate on this, but I would love to hear from some of you on this and get your opinion. Let me show you what I mean. If it would have said LN over MN is similar to or proportional to PN over ON, and these two triangles have this common angle right here, then we have side angle side, and the two triangles are congruent, and then we can go from there and say this angle is congruent to this angle, corresponding angles, the two lines are parallel. Well, that's what they're claiming in the back of the book, side angle side, but I'm not seeing side angle side. I'm seeing this side here being used with this big side here, and this side right here, LM, is not the side of any triangle that I see. So right now I'm just going to tell you what they're saying. I'm not seeing it. I would have had to have put no. Yes, I see the sides. Yes, guys, we have a rule that says, I'm trying to think here. Hold on. No, I'm wrong. I see it now. Sorry about that. We have a theorem that says if a line divides two sides of a triangle proportionally, then it's parallel to the third side. And this line, here's our triangle. And this line here divided the two sides proportionally. So yes, it is parallel. Okay, sorry about that. That is called the triangle proportionality converse. So yes, we are totally good. Okay, number 18. They're saying the triangle LPN is similar to triangle MON. Now, if these two triangles are similar, then this angle is congruent to this angle, this angle is congruent to this angle, and this angle here is congruent to this angle here. So that means this angle is congruent to this angle, and this angle is congruent to this angle. Well, guys, we know what that means right away. Corresponding angles are congruent when two lines are cut by a transversal, so that corresponding angles are congruent. Or you could say this transversal here, corresponding angles are congruent, then the two lines are parallel. So MON. So MON, this angle here, and angle LPN, LPN, this angle here. Same thing, guys. We have two parallel lines being cut by a transversal in such a way that the corresponding angles are congruent. So those two lines have to be parallel. So yes, they're parallel, and the reason would be corresponding angles are congruent. Okay, number 21. Let's see what 21 says. LM over MN equals LP over MO. No, guys, we've never learned anything like that. Now, if they would have said LM over MN equals PO over ON, then you could say yes, because anytime you have a triangle and a line is drawn connecting two sides that divides the two sides proportionally, then that line is parallel to the third side. That's a theorem that we've learned, but we've never learned anything dealing with, this over this equals this over this. So no, we cannot state from the information we're given that the two lines are parallel. They might be, but we don't know for sure. Alright, moving on. Number 22, MNO. This angle is congruent to angle NLP. Guys, that does nothing when it comes to parallel lines. It really doesn't, okay? I don't think. Let's see, this angle here is congruent to this angle here. And it's also congruent to this angle here. But we do not have two angles in this triangle congruent to two angles in this triangle, so we cannot state the two triangles are similar. We cannot state that. We don't have any alternate interior, alternate exterior, corresponding angles congruent. So no, I see no way that we can state those two lines are parallel with just that information that's given. Alright, okay, moving on to numbers 23 through 26. The directions say to use the figure at the right to match the segment with its length. Now please listen carefully. Notice, please, students, that this side here, this has a length of 2, and this has a length of 2. Do you see that? So this is the midpoint right here, okay, of this side over here. Right here. Now, notice also that, listen to me, so this is the midpoint of this red line right here. Also notice, from here to here is 4, and from here to here is 4. So this is the midpoint of this entire side over here, okay? So please keep that in mind as we do these problems. And I'm going to go ahead quickly, students, here and draw my little triangles and my bigger triangles, G, A, B, then a little bigger triangle, G, C, D, then a really big triangle. I'm sorry. There we go. G, E, F. Now let's see what we know. This length here is 2. GC is 4 because 2 plus 2 is 4. This whole length over here is 8. And then from about here to here we know is 2.5. Okay? Alright, now all of these triangles are similar. This triangle is similar to this triangle. This triangle here. This triangle here is similar to this triangle here. And let's see what else we have, students. AB is 2. Okay, they want us to find the length of CD right here. Okay, CD. So these two triangles are similar. So 2 over 4 equals 2 over x. So 2 over 4 equals 2 over x. And if we cross multiply, we get 2x equals 8. Divide both sides by 2. X equals 4. So the first answer here should be letter D, 4. Okay, moving on to number 24. I'm going to go ahead and label this now as a 4, okay, to help us. Alright, now we're going to find the length of EF, which is right here, okay. Now, let's see what we have here. We know this triangle here is similar to this triangle here, so we can state that 4, we're trying to find the length of EF, so we'll put an X here. okay? So we can say that 4 over 8 equals 4 over x. And obviously, guys, if you have a 4 here and a 4 here and an 8 here, this is going to be 8. Now, if you want to go ahead and work it out, you can. I mean, 4 times 8 is 32. 4 times x is 4x. Divide both sides by 4, and x equals 8, okay? But the answer to 24 would be 8, which should be letter A. Alright? Okay, let's go ahead and fill that in so we have that information. So now we know this is a length of 8. Alright, GB. Alright, well, we can use our, let's see, can we use our similar triangles here? Let's see here. We can call this length here x, okay? So that means this length from here to here is x. So let's be really careful here. I want to find the length of GBX. So I could say 2 over 4. 2 over 4 equals x over this whole side, which is x plus 2.5. From here to here's x. From here to here's 2.5. And that should work. So let's see what we get here, okay? 2 over 4 equals x over x plus 2.5 is 5 over 2. Alright, 4 times x is 4x. 2 times this would be 2x plus 5. Bring the 2x over and make it negative. So you're left with 2x equals 5. Divide by 2, and x equals 2.5 or 5 over 2. Either way is sufficient, okay? Which would be letter C, and that is the answer to number 25. Letter C. Alright? Okay, moving on to number, let's see, number 26. DF. Alright, let's see. Well, first of all, let's go ahead and fill in what we just learned. We just learned that this here is 2.5. So put 2.5 here. That means this whole length here of this whole side is 5. 2.5 plus 2.5. Okay, we're looking for the length of GB. This length, I thought we just found that. Oh, the length of DF. This length right here. DF. Okay, now, if we can find, we know from here to here is 2.5. So we know from here to here is 5. Now think about it. If I can find this whole length and then subtract this part out, then I'll know this part here. So I'm going to try to find the whole length of GF. Okay? Shouldn't be too hard. I'm just going to say 4. Let's see. 4 over 8 equals 5 over, and we'll call this x right here. Okay? So 4 over 8. 4 over 8 equals 5 over x. So 4x equals 40. X equals 10. So I know this whole length here is 10, all the way from G all the way down to F. This whole length from here to here is 10. Now, this is 2.5 here. From here to here is 2.5. From here to here is 2.5. So this whole length here is 5. So DF then has to be 5, because 5 plus 5 gives you 10. So the answer is 5, which is letter B. Okay? If I've gone too fast, just back it up and watch it again, okay? Alright, moving on to numbers 30 and 31. On Denny Way. So on Denny Way, the distance between 5th and 8th is 500 feet. So here's 5th. Here's 8th. So the distance from here to here is 500. And by the way, they tell us that all these streets are parallel in the directions. I should have read that to you on the map. All of the numbered avenues are parallel. So all of these lines here are parallel. Okay? So the distance is 500 feet from here to here, from 8th to 5th Avenue. Alright? What is Okay, I mean, totally similar because they share an angle, and I know this angle here is congruent to this angle here because parallel lines cut by a transversal corresponding angles are congruent. They share an angle that's congruent, so I have two similar triangles. So if this is 500 from here to here, everything being proportional, this also would have to be 500 feet. Okay, now the next one's a little more challenging, and we'll see if we can't figure this next one out. Okay, here it is. Along West Lake, so here's West Lake, between Denny and 7th Avenue, so here's Denny and here's 7th right here, is 375 feet, so the distance from here to 7th here is 375 feet, okay? What is the distance between Wastelook and Denny along 7th Avenue? So here's 7th Avenue. What is the distance between Westlake and Denny? So from here, what is the distance from Westlake here all the way over to Denny on 7th Avenue? That'll be our X right there. Well, let's go ahead and see if we can't draw some triangles here, okay, to help us a little bit. Look, guys, first of all, you've got a small triangle, okay? And then you've got a bigger triangle that covers the whole thing. Now the smaller triangle has a length here of 375 right here, and we're trying to find X, okay? Now this big triangle has 750 here. It has 1,170 here, and it has 750 here. So we have all the numbers that we need to solve for X. We know these two triangles are proportional because we have a big triangle here, like this, okay? And this line here is parallel to this line here because the direction said all of the numbered avenues, 9th, 8th, 7th, 6th, and 5th, are parallel. So if they're parallel, then we have proportional triangles. If we have proportional or similar triangles, if we have similar triangles, then we can use ratios. So here we go. I'm going to put 375 over 750. So this side over this side equals X over this side. X over 1,170. Now, I could reduce the one fraction, 375 over 70, but I'm just going to go and get my calculator and just multiply this out and be done with it. So 750 times X is 750X. 375 times 1,170 is 438,000. 750. Okay, then we're going to divide that by 750, and we should get the answer, which is 585, which is correct. So guys, all that it came down to was realizing we had similar triangles. So when these pictures here are confusing, draw the similar triangles off to the side, then write your proportion, and then solve the proportion. Okay, the answer is 585 feet. Okay, moving on now to numbers 32 through 35. Now listen, students, these are not bad, so pay attention. Okay, notice we have a triangle right here, a big triangle, okay, with a line drawn here, and these angles here are congruent. See that? Well, they also have an angle here they share. So this little triangle here, this little triangle is similar to the bigger triangle because this angle here is congruent to this angle here, and this angle here is congruent to this angle here. So this side here is 7, this side here is X, this side here is 5, and what's this whole side right here? Well, from here to here is 5, from here to here is 2, so this whole side is 7. So I have X over 7, X over 7 equals 7 over 5. Okay, we end up with 5 times X is 5X, 7 times 7 is 49. Divide both sides by 5, and you can put 49 over 5, or you could put 9 and 4/5, or you could put 9.8. Any of those are sufficient answers, okay? Alright, moving on now to number 33. Same thing again, guys. Okay, look, we got triangles drawn with the sides here that are parallel, so that means this little triangle right here, I'm going to quickly trace these to make it a little easier. This little triangle let's see what we have here, students. This whole length here is 6 1/4. This whole length here is x. This side here is a length of 4, and this whole length here is 5. So here we go. 4 over 5 equals x over 6 1/4, okay? Now 5 times x is 5x. And students, you can use your calculators and fraction buttons. 4 times 6 1/4 would be 25. Divide both sides by x, or by 5, and the answer is 5, okay? So these are pretty repetitive, these first two. And I think they're all just about the same, okay, to be honest with you, which is okay. Now this one here is a little different. Here we realize that we have a triangle drawn with a line that connects two sides is parallel to the third side, so it divides these sides up proportionally. So we can put 3.4 over x equals 6.3 over 2.1. Or we could have put 3.4 over 6.3 equals x over 2.1. Either one of those will work, okay? 6.3 times x is 6.3x equals 3.4 times 2.1 is 7.14. Now divide both sides by 6.3 and we should have our answer, which would be 1.133333. So you can put 1.13 with a bar over it, and that would be good, okay? Alright, moving on to finally our last problem of the assignment. And this is interesting here. I want you to think this through. First of all, I've got a right triangle here that I'm going to try to cut out, okay? And I've got a right triangle here. I'm going to cut out. Okay, let's label some information here. I've got an angle here. If there's a right angle there, there's got to be a right angle there also. So this is a right angle. This angle is congruent to this angle. Well, we can stop right there. Whenever two angles of one triangle are congruent to two angles of another triangle, the two triangles are what? Similar. So now let's start. Now we know the two triangles are similar. Now we know this length here is x. We know this length here is 16. We know this length here is 12, which would also make this length 12 because they share a side. And this length here is 15. Now, as you go to set up your proportions, please be careful. Match corresponding sides with corresponding sides. Let me show you what I mean. X is on this side here that has one mark and no mark on its ends. So what side over here has one mark and no mark? Here's one mark, here's no mark. So this side here, so x corresponds with 15. Make sure you match the sides up correctly. X over 15 equals now 16 here has a right angle at one end and one mark at the other. Okay, so what side in the other triangle has a right angle and one mark at the other end? Here's your one mark, here's your right angle, this one here. So 16 corresponds with 12. So here we go. X over 15 equals 16 over 12. I could reduce this fraction, but I'm just going to use my calculator. 12 times x is 12x, and 16 times 15 would be 240. Divide both sides by 12, and x equals 20. Okay? And there we go. Students, I really hope these homework videos are a help to you. I hope this one was. If you have any questions, don't ever hesitate to call or email.